Hi everyone, today we are solving this problem, linked list cycle. Given a head, the head of a linked list determines if the linked list have a cycle in it. There is a cycle in the linked list if there is some node in the list that can be reached again by continuously follow the next pointer. Internal list post is using to denote the index of the node that tail next pointers is connected to. Note that post is not passed other parameters, okay? So return true if there is a cycle in the linked list, otherwise return false. So we can come up with a really easy example like example 1 in here. We have the linked list here, which is 3, 2, 0, and -4. But we have the poles here, which represents as a cycle in here. So as you can see, -4 in here, not the last node, but let's point back to node 2 here. So there is a cycle in it, so it will output true. And in example 3 in here, we don't have the cycle, which is posed in here. You can see it is -1. And the head is only have one node, it's not 1 here. And we don't have any cycle, so we just return false. With these problems, we can ask the interviewers, what if the header of the list is null? What we do in this case? So in here, we can find out that the number of the node in the list here can be null. And I think in that case, we can just return false because it's not have any cycle. When we consider the edge case, we can see as a follow-up here. Can you solve it using one constant memory? We cannot store it in any data structure. Let's see if we can do it in the planning and matching step. We have example 1 in here, and there is a cycle inside it. Normally, we were thinking about like doing some data structures so we can keep checks if there's a node 2. So in this case, we can doing a hash set and then put every node inside the set there. And whenever we come back to the node 1 to one node, and which is already contained in the set, then there is a cycle inside the linked list there. And if not, then we can return false. But in that case, we are using O of n space complexities, since we'll have to storing every node. But we want to optimize the space complexity to constant memories in the follow-up questions we have. So with that, we also thinking about other way we can keep tracks of what node it visit. And there is two-pointer technique. So with two-pointer in here, we have calculated really special case in here, fast and slow pointers. With the slow and fast pointer techniques, the slow pointer will start at the head, and then the fast pointer will start at the node next to the head. So we will have this. And then we will keep moving until the slow pointers equal to the fast pointers. That means there is a loop there. Because if there is not a loop, then the fast pointers will always faster than the slow pointers. But if there is a cycle, then the fast pointer grab around, and then the slow pointers catch up with the fast pointers, and then it will meet at the same pointer. So to demonstrate that, we will go through this example. So the fast pointers here. So at first it will look like this. The next times we will move the slow pointers by 1, and then move the fast pointers by 2. So instead of fast here, fast will skip 0 here. It will move to 4 here. So as you can see, the gap between the slow pointers and then the fast pointer is getting larger. Next step, we will continue to do that. So the next one, the slow pointers move to 0 here, and then the fast pointers will grab around. So it will skip 2 here, it will get to 0 here. So as you know, in here, it will point to the same one. So this means like, that there is a cycle in there, because right now, fast and slow pointers is pointed to the same node. So we can calculate this one is true. To make sure this fully works, we will go through no cycles example. We can have 3, 2, 0, and 4 here, which is the same, but we don't have cycle there. Node 4 is pointed to null into the end of the node of the linked list. So we still work with the fast and slow pointers. So fast pointers point to node 2 here, and slow pointers point to node 3 here. Slow pointers will point to node 2 here, and then the fast pointers will skip 0 and run to node 4 here. And in this case, we continue that. We can see that if we move next, we can see snow pointer is still in the bounds of the linked list, but the fast pointers is out bounds already. So we can see that the snow pointers and fast pointers will never meet each other. The graph is larger, as you see in here. So it will never meet each other when there is no cycle. So this one is written false. So with these techniques, we can see whether there is a cycle inside a linked list or not. So next we will move on to implement step. In these steps, I would do it in Java, but I also have the Python solutions in the description below. So please check it out if you're familiar with Python more. So in here, as I said, we also have the edge case is the head is null. So firstly, we have to catch that first. So if head in here is null already, so we just return false right away, since we don't have any cycle with the root is null. Next, we will have the fast and snow pointer technique. So we will create the snow pointer first, snow pointer here, which will point to the head of the linked list. And then another node is a fast pointer, which points to the next of the head. Okay, so in here we know that we will have the while loop, while the snow pointers is not equal to the fast pointers. Then we continue to loop through. And if we know that the snow and fast pointer is equal to each other, then we know that there is a cycle inside that, like the examples I demonstrate in the plannings and matching step. So we return true. While the snow and fast pointers not met each other, firstly we need to check if the fast is null or the fast pointers next is null. This one we want to make sure it is not out bounds, because when we have the second example in the planning matching step, the fast is null and then the next pointer which is also null, so we know that there is not a cycle inside the linked list. So in this case we return false. We don't get to the return statement in here in this if condition, so we know that fast and snow pointers can still be increased. So we just moving the snow pointer by 1 with snow.next here, and then the fast pointers go faster than snow pointers, so .next here. So this is how we demonstrate the go through one by one. So we complete this. So next we will move on to the testing step. As you know, we don't have the IDE like this in the interview settings, so we will go through it by hand. So at first, our fast and snow pointers we will have things there, fast and snow pointers, and then in here snow pointers will point to head is 3 here, and fast pointer will point to head.next is 2 here. So we compare 2 and 3, which is not equal to each other. So we check the if statement here, and fast is not null, fast.next is not null, so we skip it and we move the pointers. So snow here is 2, and then fast here is point to -4. And then we check the snow and fast pointer again. So in here, fast and snow pointers is not equal to each other. We go to this part neck, and fast is not null, fast.next is not null as well. So we're still moving the snow and fast pointer. So in here, snow pointer is at 0, and then the fast pointer next will be 0 as well. So at this point, we compare it, and we know it's part of the same one. So we skip our while loop, and it's written true. This means our solution worked. Just run to example test case here. Okay, it's get accepted, so it means it's worked. So we have time complexity in this one, which is O of n, since we have to loop through every node one time. And then we will have the space complexities. It will be O of 1, since we just keep track of slow and fast pointers. So it's just of 1 constant space. Make sure everything works by submit this. Okay, so we have the successful result here, and this solution is faster than 100% of all Java Online submission for this problem. So as we complete these problems, please let me know if you have any questions or more challenge you want me to do in the comment below. And please like and subscribe to my channels. Check out other videos as well. Thank you.